Suppose you need to know the volume that will be occupied by 10 kilomole of hydrogen at negative 150 degrees Celsius and 500 atm absolute. Would you consider it reasonable to use value calculated from ideal gas equational state? No, right? Because obviously the molar number is so big, it's 10 kilomole, and the temperature is negative 150 degrees Celsius. We know that for ideal gas, temperature has to be greater than 100 Kelvin, and the pressure had to be around 1 to 3 atm, and you get 500 atm here. Absolute is way too big to be ideal gas, so it's not reasonable to use ideal gas equational state. How would you use generalized compressibility chart for this equation, for this calculation? Okay, well, first of all, we had to calculate the reduced temperature and reduced pressure. Use the given temperature and pressure, because we talk about the exception species is hydrogen and helium, and hydrogen is given right here. And we had to use the adjusted pseudo-critical constant. And for the critical temperature, we can find from chemical engineer's handbook, or you can find from the back of the textbook just for problem practicing. You can find that in the table B.1. And for hydrogen, okay, I can tell you real quick. On page 631, you can find that the T sub C for hydrogen is 33.3 Kelvin, and with the adjusted equation 33.3 plus A, that's the adjusted pseudo-critical temperature, and the critical pressure for hydrogen gas is 12.8 atm, and we had to use that to plus 8 atm. Then you will get the adjusted critical pressure. Then when you get the adjusted critical temperature, then you can use that to calculate the reduced temperature. Remember, this T sub C here for hydrogen gas had to be adjusted value, not the true value, not the value you found in the book. So this actually had to be written as T sub C adjusted. But you know, when you are calculating the species of hydrogen or helium, you had to use adjusted value. Okay, and do the same thing to adjust the pressure. You find the adjusted pressure from the book. I just told you that 12.8 atm. Then plus 8 atm, then you got 20.8 atm. And use this adjusted P sub C to calculate the adjusted value for the reduced pressure. Actually, the way you write is not right, because suppose you have, well, oh no, I'm sorry, yeah, it does not have unit because the unit cancel out, right? Okay, yeah, that's right. Your unit cancel out, so the reduced temperature, reduced pressure is actually dimensionless. Okay, now we can find the Z value from the generalized compressibility chart in the book. Your compressibility chart look like this. Okay, first of all, you have to calculate T sub R, right? And P sub R. Let's go to the textbook and find the T sub R value. The T sub R is something like this. It's something like across the table. It's a weird looking shape. It's shaped like a V. Whatever, you cross the table and look for T sub R is Remember the T sub r is like this weird shape, but when you see across the table there's a dashed line and there's a solid line, look for the solid line for T sub r value and look for P sub r. From the x-axis we have calculated P sub r, pressure, reduced pressure is 24. 24 is very big. Okay, figure 5.4-4, that is for the pressure over in the range from 0 to 40, and look for 24. Then you find 24 close to 25, and once you find 24, for example, well, we don't have a graph like that, but if you find the P sub r and then you found 24, and then from there you go up. Once you go up and then you'll meet a solid line, the solid line is the T sub r we calculate is 2.9, well, close to 3, so you can look for 3. It has 3.00, so from 24 go up, and once you meet 3.00 and then go across the table, and then to meet the y-axis, then you can find the z value is close to 1.6, a little bit about 1.5, so it's 1.6. We can say 1.61. Okay, now that we calculate the T sub r, P sub r, and then we found the z value, then we can use that to calculate the volume in the compressibility equation of state. Just simply replace all the value you found and replace this equation. The reason we calculate T sub r and P sub r is only to find the z value from the compressibility chart, but you don't use it to calculate that in this equation. You had to use the absolute pressure and temperature given in the problem statement to calculate the unknown variable. Did you get that?